About 3 billion kilometers from Earth, there exists a world that seems to have been forgotten by time. While the entire solar system follows orderly laws, this entity chose rebellion, a planet that does not stand upright, but instead lies tilted in eternal darkness. Behind its calm exterior hides a frozen hell. A place where winds tear apart sound, where the sky rains pure diamonds, and the atmosphere reeks of rotten eggs. It is time to return and decode the sleeping giant. As the seventh planet from the Sun, Uranus is an isolated icy oasis located about 2.9 billion kilometers from Earth on average. While most planets in the solar system rotate on nearly upright axes like steady spinning tops, Uranus is a bizarre exception. Earth tilts at a modest 23.5 degrees to create 4 seasons, but Uranus is tilted a staggering 98 degrees. This extreme tilt completely overturns the concept of day and night as we know it. Although the planet spins relatively quickly, taking only about 17 hours to complete one rotation, its sideways orientation prevents sunlight from being evenly distributed across its surface. As a result, each pole alternately faces directly toward the Sun for half of its orbit. Uranus takes 84 Earth years to complete one orbit around the Sun, meaning a single location on the planet can experience 42 continuous years of daylight, followed by 42 years of complete darkness. This extreme tilt is not just a number, it is the cause of one of the harshest worlds imaginable. From a distance, the planet appears in a soft, pale blue color. This hue is created as methane in the atmosphere absorbs red light and reflects blue light. However, compared to Neptune, the difference is striking. Despite having similar compositions, Neptune appears deeper and more vivid blue, while Uranus looks paler and more faded, almost lifeless. The reason lies in a thick haze covering the planet. On Neptune, active atmospheric dynamics help reduce this haze. But on Uranus, the lack of internal heat results in a less active atmosphere, allowing the haze to accumulate and dull its color. But don't let that calm appearance fool you. Beneath that smooth exterior lies a massive freezer, with temperatures dropping as low as -224 degrees Celsius, making it the coldest planet in the solar system. Strangely, despite being closer to the Sun than Neptune, Uranus is significantly colder. This is because its core emits almost no internal heat compared to other gas giants. However, that stillness is deceptive. Beneath its atmosphere of hydrogen, helium, and methane are violent winds exceeding 900 kilometers per hour, moving fiercely yet extremely difficult to observe from the outside. Deeper inside Uranus, immense pressure begins to break apart methane molecules. At depths of around 7,000 kilometers, carbon is released and compressed into diamonds, creating continuous diamond rain deep within the planet. Hearing this, many might wonder, if we could reach this planet, could humanity exploit an endless treasure? On Earth, diamonds are rare because they take billions of years to form. Here, they are produced continuously in massive quantities. But it doesn't stop there. As you go deeper toward the core, temperatures rise to thousands of degrees Celsius, enough to melt diamonds, forming regions of matter like oceans of liquid carbon. At the center, matter exists in a strange state called superionic ice, a form that is both solid and allows charged particles to move freely. This unusual state is what causes Uranus's magnetic field to be tilted and irregular. This shows that diamonds here are not treasure, but merely a natural byproduct of extreme pressure and temperature. And even ignoring their value, extraction is nearly impossible. The atmosphere is filled with hydrogen sulfide, a toxic gas with the distinct smell of rotten eggs from decomposing organic matter. It is not just an unpleasant odor, but a deadly sensory nightmare. Just one breath of this gas would paralyze your nervous system instantly before your body could freeze into a permanent block of ice. And that is only the outer layer. The deeper you go, the pressure can crush any material, while temperatures are high enough to alter even diamonds. More importantly, even if humans could reach this place, the cost of extracting and transporting diamonds back to Earth would be so enormous that they would become completely worthless. So what created such a strange world? Scientists believe that about 4.5 billion years ago, Uranus collided with a celestial body roughly the size of Earth. A collision on that scale would release energy billions of times greater than the total nuclear arsenal on Earth, enough to completely alter the rotational axis of an entire planet. However, what's unusual is that Uranus does not emit as much internal heat as expected. This has led many scientists to suggest that instead of a single massive impact, there may have been multiple smaller collisions accumulating over time. In other words, this planet may be the result of a prolonged series of impacts rather than a single event. And if that is true, then what we see today is not just a tilted planet, but the lingering scars of a violent past in our solar system. Looking at that permanent scar, one cannot help but shudder and wonder, if such a catastrophic scenario happened to Earth today, would humanity have any chance of survival? The answer is almost certainly no. Even before the collision, the immense gravitational forces alone would be enough to destabilize Earth entirely, triggering earthquakes, tsunamis, and the collapse of all ecosystems. As the two planets draw closer, Earth would be torn apart and rapidly heated. and when the collision finally occurs, our planet would completely melt and cease to exist. With current technology, from the moment Earth begins to lose stability, humanity would have only a few hours, at most a few days, before everything ends. Beyond Uranus itself, what fascinates scientists just as much is its unusual system of moons and rings. Surrounding the planet is a ring system of at least 13 rings, but unlike the brilliance of Saturn, these rings are dark, faint, and almost invisible in space. They are composed of dark rock and ice fragments that absorb light rather than reflect it, making the entire ring system look like cold scars encircling the planet. With 27 moons orbiting it, Uranus does not display grandeur like Saturn, but instead hides eerie and unsettling peculiarities. The most striking is Miranda, a celestial body that looks like a Frankenstein monster of the universe. Looking at Miranda, you get the impression it was once shattered to pieces and then crudely reassembled, creating a patchwork surface with massive fractures. Even more astonishing, it features the Verona Rupus Cliff, rising up to 20 kilometers high, twice the height of Mount Everest. In its extremely weak gravity, if you were to fall from the top of this cliff, you would spend up to 12 terrifying minutes suspended in mid-air before hitting the ground. Yet behind that ruined and lifeless appearance, another secret is beginning to emerge. For many years, we considered this a silent, frozen world, but the latest research suggests that beneath the thick, icy crusts of moons like Ariel and Titania, there may exist oceans of liquid water. Despite surface temperatures dropping to minus 224 degrees Celsius, internal heat within these moons may still be sufficient to prevent the water from completely freezing. If this is true, then even in a distant, harsh, and seemingly forsaken place like Uranus, life could still be quietly existing in the dark crevices beneath hidden oceans. To this day, what we know about Uranus remains very limited. In 1986, the Voyager 2 spacecraft flew past the planet and collected data. But there is something important we did not realize at the time. At the exact moment Voyager 2 passed by, Uranus was being affected by an extremely powerful solar wind. This solar wind distorted the planet's magnetic field, making what we observed appear unusual. Meanwhile, such conditions occur only about 4% of the time. This means that the only data we have may not accurately represent the true nature of Uranus. If the spacecraft had passed at a different time, we might have seen a much more stable planet. And in that case, the conditions within its moon system, such as the possibility of subsurface oceans, could also be significantly different. Currently, due to the lack of direct data, many questions about the planet's structure and history remain unanswered. New missions are being planned, but it may not be until the 2040s that humanity can return to study it more closely. Uranus, therefore, is not just a distant planet, it is also a clear example of the limits of our knowledge. For decades, we have relied on a rare moment to describe an entire world. And when we look toward that cold blue planet 2.9 billion kilometers away, one question remains unanswered. Have we truly seen its real face, or only a fleeting illusion of the universe?